Bismillahirrahmanirrahim. Alhamdulillahirrahmanirrahim. Wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Allahumma la sahla illa ma ja'altahu sahla wa anta taj'alul hazna idza shi'ta sahla. Okay, assalamualaikum and very good morning to all of you. So, can you hear me?
Waalaikumsalam, Doktor. Kan, Doktor?
Can, Doctor? Yes, Doctor.
All right. Okay. Let me fix something. Okay, guys, can we start?
Doctor.
Yes, Doctor.
Okay, so let me start. So last class we have covered until this exercise, isn't it?
Yes, Doctor.
Okay, let's proceed to the next one, which is the equilibrium system. Okay, it is similar like to the analysis to the dimension to dimension last week. So basically, you have to apply this the first step. Alright, so you have to use this equilibrium equation where the resultant or the total forces must be equal to 0. Okay, so you have to use this when you want to solve the problem. If the problem is in equilibrium system, so you have to use this formula. And because of the 3D, you have to have a IJK form. Okay, so meaning that every single component have their summation of forces as well. So for the x component, we denote it as a summation of fx. For y component, summation of fy, and the z component is summation of fz. Okay, and the total should be equal to 0. Okay, the first Newton's law. Okay, if you want to find the forces for each component, okay, if you want to find F1x, okay, you have to use I component and must be equal to 0. If you want to find F2y, okay, you have to use Y component, J component, and the summation of forces must be equal to 0. And the last one is, of course, the Z component, Fz equal to 0. Okay, so yeah, some exercise, some problem where you need to identify the unknown value of force. Okay, because the previous one we just only to find the resultant. This one, exercise 2, exercise 1. Okay, from here we just need to find the resultant. And some examples, some problem, you may need to find the force. Okay, you may need to find the force. Okay, so let's begin to example. Okay, all right, like this. You have to determine F3 if the system shown below is in equilibrium system. Okay, so the F3 value is unknown. The known are only two. Okay, F1 1000 Newton and F2 880 Newton. Okay, and you have to determine F3. So bear in mind that this is the 3D. Okay, meaning that all forces must be in IJK form. Fi in terms of IJK form, F2 must be in IJK form, and same goes to F3 must be in terms of IJK form. All right. Okay. So before we start, just want to ask you how to start. Okay, what we should do actually for the first step?
We can find the resultant for the F2.
Yes, how about F1?
The third method.
The third method.
Dist
Okay.
distance one.
Yeah.
Coordinate method.
Yeah, coordinate method. Yeah. How about F1?
First angle method.
Yes. Yes. How about F3?
Second angle method.
Second angle method.
No,
How
doctor.
come we
First
use
one.
second angle method? Because there is no angle acting on the force 3.
First angle method.
Yeah, the answer is equilibrium for 3D. Yes. Okay, so the first step, of course, you have to recite Bismillah. Bismillahirrahmanirrahim. Okay, so before you start, you have to Bismillah lah. Okay, for the Muslim lah. Okay, all right. So yes, this is the pen. Okay, this is the thing that you have to do. Okay, you have to transform. Okay, I use the word transform these two forces into IJK form. Okay, you have to transform it into IJK form. Okay, this one as well. IJK form. Okay, and this one also in terms of IJK form. Okay, all right. So the first force, okay, which is, let me do this thing first. Okay, the first force, okay, this one, since you have this angle, okay, all right, and this angle, unknown angle, you can use first angle method to get IJQ form. And the second force, you have this value, you have to use third method, which is coordinate method, okay, to get this IJQ form. Right. So can you calculate first for the F1? I want to see the answer. You have to practice right now. Yeah. What is the value of forces of the first one? Okay, in terms of IJK form. Do it now. Please do it now. Are you doing right now? So the first one, you have to find the theta z. How much for the theta z? Theta z 120 degree. Okay, so you will get two value actually, 60 degree and also 120 degree. So Junaid said that you chose 120 degree, and my question is why?
Negative side.
Negative side of
Z.
Z. Yes, correct. Because if you look at the Z axis, this is the Z axis. Okay, the angle from this axis to the line of force. Okay, this is the angle. Okay, if you look at this plane Y, Z, okay, the force is below, sorry, is above the 90 degree. Wait, okay, the force is like this, F1, okay? So you should choose 120 degree instead of 60 degree. Okay, great. Okay, so what is the answer for F1 in terms of IGK form? Anyone got it? Is there anyone got it?
Doctor,
Yeah,
707.1 for I, positive
707, yes.
0.1.
Yeah, correct.
And 500 positive also for Y, for J.
Yes, correct. And for the Z component? Yeah, the answer is in the
minus 978.14.
no, wrong. The Z component
Negative
500.
500. Yeah.
Yes. Okay, so this is the answer. Wait, this is the answer for F1. Okay, F1. So you got the theta Z 120 degree. Okay, substitute the value of theta X, theta Y, theta Z, and F1 into the equation. You will get the final answer of the F1 in terms of IGK form. Okay, so make sure. Okay, make sure this. Okay, make sure this. Oops. Make sure this. Hey, sorry. Fine. Okay, make sure this sign must be correct. Okay, if you want to check the answer, is it correct or not in terms of the position, in terms of the direction, either positive or negative, you have to check again the force belong to which part. Okay, so you can see that is the you can see that the Z component should be negative because it's behind the screen. Okay, behind the screen. Okay, so this one should be positive lah. Okay, this one should be positive as well. Okay, only one thing, only one component is negative. Okay, for F2, how about F2? So you have to determine dx, dy, dz first, and then you have to determine d. Can you do it right now? What is the value for dx, dy, and dz? Anyone?
dx 0.6.
Dx 0.6, dy. Oops. Dy.
Negative 0.7.
Yes, negative 0.7 for dy. Dz 0.6 is correct. So what is the value for d? D is equal to 1.1. Okay, yes, correct.
Right, correct. Yeah.
Yeah, so you have to substitute those value into the equation. Okay, you will get the final answer of F2 in terms of IGK form like this. Okay, the equation of the coordinate system is this one. Okay, so substitute all the dx, dy, dz, d, and also F2 into the equation. You will get the final answer. Okay, easy, right? Okay, this is only the resultant. Okay, resultant for F1 and F2. So back to the question, you have to find the equilibrium system. You have to find the F3 if the system is in equilibrium system. Okay, so you know that F3 is also should be in term of IGK form. Okay, in term of IGK form as shown in the slide. Okay, so this one. F3 equal F3xi plus F3yj plus F3zk. Okay, and we know that every single component have their own equilibrium. Okay, so each component must be equal to 0. The summation of fs must be equal to 0. The summation of fy must be equal to 0. The summation of fz must be equal to 0. Okay, all right. Okay, so if you don't like this method, I have additional method which you can avoid to have this long writing. Okay, like this one. Let me show you. Okay, so just use one single component like this equal to 0. Okay, all right. So you have to put all the forces of the x component. Okay, this one is F1, this one is F2, this one is F3. Okay, so you will get the answer F3 equal to negative 1, 1, 1, 1, 8, 7. Okay, so you can do one by one like this. The y component, for the y component, 500, okay, minus 560 plus F3. So I forgot to put x here. X, F3x, this one F3y equal to 0. Okay, you will get Fy. Okay, and the last one, of course, Fz must be equal to 0, negative 50 plus 480 plus F3z equal to 0. You will get F3z to 20 Newton. Okay, so once you have this value, okay, this value, you have to put it into the equation to represent the IGK form. Okay, and finally this is your answer for F3. Okay, so far so good, is it?
Still easy until now.
This method is okay. Which one method? Which method? Rabiul Hassan, which method that you said just now? Previous one. Previous one. Which one? Rabiul Hassan, which one? Previous one, which one?
Summation of fs, summation of fy, summation of fz equal to 0. Which one?
Okay. All right. Is there any questions so far before we proceed to the exercise? Any question? No. Yes. No. Okay. If you want to know the question later on, you will get the question when you want to solve the problem. Then you will know what the question that you want to ask. Okay. So let's proceed to the exercise. Have you done this one? Have you done this one?
Doctor.
Huh?
No, doctor.
No. Okay. Can we do it together right now?
Okay, doctor.
Right. So let's do together. Okay. Right. So the system is like this, as shown. Okay. So there are four forces acting on the origin, acting on the system. Okay. Acting on the origin. T1, T2, T3, and the mass. Okay. So the question asking you to find the value of T1, T2, and T3 to maintain equilibrium. Okay. So the meaning that the unknown of are three. Okay. And the known value is only 30 kilogram. Okay. So what you should do first? What you should do first?
We find T3 by first method.
Okay, yes. Okay, yes. Only T3?
No, we can also find T2. I mean, there is the 30 kg.
Mm-hmm.
30 times
Yeah.
9.8 and
Okay. Let me show you the basic step that you need. Okay. So because you are using equilibrium system, you have to make sure that all the forces must be in resultant form. Should be in resultant form. So you have this T1, T2, T3, and mass. So the first thing that you have to do is to convert this into IGK form. T1 plus Y G plus T1Z K. Okay. You have to transform T1 into IGK form. Same goes T2. Okay. T2XI plus T2YG. Okay. And T2ZK. Okay. And same goes to T3 and mass. So the first one, the first T1, which method that you have to apply? This is tricky. Which method for the T1? Any idea? T1? T1?
Cosine
Hello. Is there anybody there?
T1 cosine the angle and sine the angle for x and y.
Yes, T1 sine angle.
No, I mean T1 cosine the angle and T1 the sine the angle for the y.
No.
The components of.
Doctor, we can find T1 by the equilibrium rule by finding T3 and T2 and the 30 kg. Because we don't have any angle for T1. We have angles for T3.
Yeah, I understand. But again, you have to transform the T1, T2, 3 in terms of IGK form first before you solve the T1 value.
Yeah, that's
Okay, so
I mean that.
okay, my idea, the idea to solve this problem is actually you have to perform a matrix actually, matrix in mathematics. Okay, you have to perform like this. Okay, all right. So you have A, B, C, D, E, F, G, H, I. Okay, and so on, X, Y, Z, for example. It is the idea. Okay, so okay, for the T1 is actually, if you look it carefully, there is no component for X and Y. Am I right?
Right, but we can know the negative side of each one.
Yes. So for the T1, D is no value. Okay, so T1 is only negative T1 Z. Okay, this one, the first equation. Okay, and the T2, it is on the plane, meaning that there is only two components involved. Okay, there is two components, and the component that involved is X component and Z component only. This one, no value. Do you agree?
Yes, perpendicular, because it's perpendicular.
So you have to write T2 equal to T2 Xi, okay, plus T2 Z. Okay. Okay. So for the third component, for the third force, which is T3, you have all the components. Okay. So you have to use the angle here. Oops. You have to use the 30-degree angle, 75 degrees, and also 115.3 degrees. Okay. Can you do it right now to convert T3 into IJK form?
Doctor, in the T2, why we cancel the Y component?
Because Y component not there. The force is on the plane, this plane.
Okay.
This plane only. So meaning that it is a 2D if you look at the X and Z axis. Okay. That's why the plane is in green color.
Okay, doctor.
Okay. Cos 115.3 I plus 3 cos 30 degree J plus T3 cos 75 degree K. This is your T3 in terms of IJK form. And the last one for this one, okay, how many components involved for the mass?
Only one.
Yeah,
On
which
the
component?
Y.
For the Y. And
Yes. So let's say I put it T4 lah. Okay, and T4 only Y, and it should be negative value, is it?
yes.
Okay, Y, okay. This is your T1, T2, T3 in terms of IJK form. So you can simplify T2 into simplify equation like this. T2 cos 20 degree I, okay, plus T2 sine 20 degree K. Okay. Right. So what's next? So what's next? This is mathematics. After this is all mathematics. Find T3 by summation of y component. Yeah, y component. So you have, yes, correct. Okay, if you look at this, let me pick one pen, yeah. Okay, so y component, which one is y component? This is y component. Lemak. Wait, okay, this is the y component. Okay, y component. There is only one component for y. Sorry, there is one value for y. Yeah.
Yang the T4 is supposed to be Y component, right?
Yeah. Sorry. Thank you. It should be J. Thank you lah. Okay. So this one is also Y component lah. Okay. So you can use equivalent system of Y component to get T3. Okay. Tak cukup whiteboard lah. Kejap. Let me. Okay. What happened? Alamak. It's lagging. Give me some moment. Okay. Ayah. Okay. Ayah. Let me erase all those. Ayah. Kejap ya. Wait lah. Okay. So basically, let me write the T1, T2, T4, T3 again. T1 is equal to negative. Okay. T2 equal to 2 equal to T2 cos I sine. Okay. T equal to 2 equal to cos 115.3 I 30. 7, 5. Okay. And the last one is T4. Okay. So using this equilibrium, actually, okay, using this equilibrium, for this system is very simple. No need to have matrix. So you can see there is two components. There is two value for y component. Okay, which is this one. Okay, and this one. This is y component. Y component. Y. Okay, and from here using this system, using this equation, you will get straight away T3. Okay, equal to something. Can someone calculate for me what is the value for T3? Yeah, the answer is
339.48.
339.8 Newton. Okay, correct. So what's next? So what's next?
We can find T3. I mean for the resultant for T3.
Okay, so to reduce the time, no need to find the resultant, just use T3. For example, okay, you use a y component. Okay, you use y component. So in this, you have two value of, sorry, not y, x component, sorry, x component. Okay, so you have to use just only x component to solve the things. Okay, you have to use the simplest equation first. Okay, so this one we do have T2 cos 20. Okay, plus T3. T3 is already there, 339.8 cos yeah, cos 115.3. Okay, and must be equal to 0. Okay, so you will get T2 here. So how much? T2 how much?
154.
T2 is 154.6 Newton. And the last one, the last component is Z component. Z component. The Z component. Okay. Z
Doctor,
component, since we do have two T and since we have a T2 and T3, then we can get T1. Okay. So just use the equivalent system, negative T1Z. Okay. Plus 2T, 154.6 sine 20. Okay. And then plus T3, 339.8. Okay, cos 75 and equal to 0. So you will get T1 Z or T1 equal to, oops, 140.8 Newton.
Doctor, T2 positive or negative?
T2 positive and negative, which one?
I think negative, yeah.
Let me check. T2
Yeah, Dr. T2 in the X side, it should be negative. Maybe you forgot.
Do you mean this value 152, 154?
Yeah, negative, yeah, doctor.
Yeah. It should be negative. Negative. Yes, correct. Should be negative. Yeah, should be negative. So how about value T1? T1 value. T1 value, is it 140? So Maria said that 140.8, 41. Is it correct?
Negative, Doctor, I think T1.
Negative, yes, because, oops, negative.
Yes, Doctor.
This one should be negative lah, right? And you got negative 140, is it? So everyone, do you got it? Everyone?
Yes, doctor.
Okay.
Negative 35, Doctor, I think I get.
Okay, how about others? Do you get negative 35?
Negative 35.07.
Can someone else check the answer? Okay. Got the same answer. Right. So the answer from the slide is wrong. Okay, so any question before we proceed to the next exercise? We do have 7 minutes left. Okay, let me check. Did you calculate? How come you get?
The different Doctor in the slide, I think the
Correct.
T2 is positive.
Guys. So
Yeah.
I think there is something wrong with your calculation right now. So supposedly the value 42 should be positive. Let me check. It should be positive actually. This one is positive.
I think negative, because if we remove the 339 to the other side and divide by cosine 20, it will be negative.
Okay, let me check again.
I think it's positive because when we put positive
Yeah.
sine 20, the value will automatically
This one
become
is
negative.
Yeah, correct. This value cos 150 is negative value.
And doctor, T2 cosine 20 is negative because it is in the negative side for the x1.
Okay, this one is positive. This one is positive. 154.6. The answer is 54.6 positive. So this one is wrong as well. So meaning that the answer from the slide is correct. Okay, let me check again. The answer for the T1. Okay. And this one is 140.8. Yeah, the answer is similar like shown in the slide. So make sure that you where is the other one? This one. Okay. Make sure that you calculate very carefully, okay, to avoid mistake like this. Okay. Okay, do you get it?
Yes, Doctor, correct.
Okay. So it is good to have this discussion actually. So we can see where is the mistake, we can see where is the wrong. Okay. All right. If no question, let me proceed to the next, the final, the last exercise for today before we end the class. Okay. All right. So this system having 1, 2, 3, 4, 4 tension, 4 wire. Okay. Let's say I put it wire lah. Okay. And you have to determine the tension in the cable OA, this cable OA, and the force F1 and F2 if the system is in equilibrium. Okay. So you can do right now. Can you do right now to get the answer? Also, I will do together with you. Okay, you have only 3 minutes left. 3 minutes. Mm-mm. Mm-mm. Okay. Let's do together. You have to do it by yourself or also we'll do on the screen.
We have tutorial class, Doctor, after this.
11.
Yeah, 11, yeah, to 12.
Oh, okay. So, okay, means that you have to do it by yourself, okay? So you do it by yourself for the exercise 2 and also the exercise 3. Okay, the answer is given there. You can try by your own.
I mean tutorial statics.
No, I don't decide yet
Oh,
because
sorry.
some of you got class at
Oh,
11, is it?
I
So
think
I think we have to discuss this thing in WhatsApp. Because you have start the class at 11, so I let you to do by yourself first. Okay, if anything wrong, if anything that you not know or maybe have trouble, you can let me know. Okay, are you okay with that?
Okay, doctor.
Okay, so the answer is given there. And for the next exercise, I will give the exercise based on this book, based on this book. Okay, based on the book that you buy.
For the tutorial?
Yeah, for the tutorial. Okay, so I think that's it for today. The time now is 11 a.m. Okay, thank you so very much. And see you next week. Okay, guys, thank you.
Thank you,
Thank you,
Doctor.
Doctor.
Thank you, Doctor.
Thank you, doctor.
Thank you, Doctor.
Thank you, Doctor.
Doctor, can you share the QR again?
Kenapa?
Tadi saya terlambat sikit je masuk.
Tak boleh lah. Kenapa lambat?
Tadi saya tolong sedia kain sekejap.
Oh, sediakan kain saya sekali.
Boleh doktor kalau saya ada sana.
Saya dah tutup lah QR code. Tak apalah, nanti saya set manually lah.
Oh ya ke? Okey.
Okay.
Terima kasih, Doktor.
Okay, Hadi Lokman. Okay, alright.
Thank you, Doctor.
Okay. No Nadira, Ani Sofia, are you there? Naif Walid. Are you still there? No Nadira, Ani Sofia, are you there?